So today we're going to be looking at transformation of exponential functions. So we're going to be moving it around. It's very similar to what we've done with quadratics and absolute value. It's going to be the shifts. So first off, what happens if we have something being multiplied times in front of it? So if we have, in all of these, the parent function has to be given to you, the b has to remain the same, so that 2 has to be consistent. And so we're looking at the parent function being y equals 2 to the x. And just so you can remember how the graph looked, here it is. And remember we talked about with that, the y-intercept is going to be at 0, 1, and the asymptote is y equals 0. And we did not talk about domain and range in the last one. Domain is all reals, which is best written as from negative infinity to positive infinity. And range is going to exclude that line that the asymptote is on. So we're going to end up having a parenthesis in this case at 0, because that's where the asymptote was. Remember the what? And this is just, I'm giving you this information for the parent function on this one. And the range is going to start at 0, and it's going up to positive infinity. And so what I wrote in purple is all the information for the parent function. Now let's look at what is happening with that transformation. I'm just using Desmos to graph these two. The blue is the new. And so when we look at this, what happened is it looks pretty much the same, except for it looks like someone pulled up on that blue. And instead of it going through 0, 1, it's going through 0, 3. And if you have trouble seeing that in the calculator, just remember that you can always do 3 times 2 to the 0 power. And so it's going to be 3 times 1, which is 3. The asymptote, what line does it look like it's not going below? Well, the asymptote doesn't look like it changed. And so the asymptote is y equals 0. Domain. The domain for all exponential functions is negative infinity to positive infinity. No matter what, your domain is always going to be this. Range is going to start at your asymptote, and so our asymptote was 0, and go to infinity if it's a growth. And we'll look at what happens if it's a decay or going down here in a second. If it's going down here in a second, excuse me. Not a decay. Decay is the same. So I actually put a third one in there. So now let's look at this graph. And so what do you think is going to happen with that negative 1/3 in front? Which of these things do you think is going to change? Or is there any of them that are going to change? Answer that question. So when we graphed it, you saw that the y-intercept changed. But our asymptote, we're still just getting really close to that line, y equals 0. So that didn't change. Domain, I said, is not going to change. So we find out the next two. So let's figure out what the y-intercept is. And so when I used Desmos, it gave me a decimal. And most of the times on the computer, it's not going to let us put in the decimal. So we need to figure out what that is by hand. So negative 1/3 times 2 to the 0 power. We're just putting a 0 in for x. This cancels out to a 1, so negative 1/3 times 1 is negative 1/3. So it is 0, negative 1/3. Range starts at your asymptote. And do you think the range changed any on this one? Well, it did, because it doesn't go from the asymptote up, it goes from negative infinity to the asymptote. So we're actually going to start at negative infinity in this case and go to where our asymptote is. So this is either going to be your start or your stop point for your domain each and every single time. I mean your domain, your range each and every time. Now I want you to graph this on your own. Look at the graph, see if you can answer these questions. So you should have been, I know in the question on the book it didn't give you all of it, but the asymptote was y equals 0. The domain was negative infinity to positive infinity. And the range is from 0 to positive infinity because it was going up. It was compressed in this case. And the y-intercept was at 0, 0.5 or a half. Because it's in a decimal in the equation, I'll go ahead and put 0.5. But it could go either way. And so, just kind of summing up these transformations, the A, if it's negative, it's going to have a reflection across the x-axis. If it's greater than 1, it's called a stretch. If it's between 0 and 1, it's a compression. And in the graphing, when you're graphing these, it's going to ask you what the compression is or what the stretch is, and you just put the numbers in the right spot. So now, what happens if we add something to the end of the function? What's that going to shift with? So instead of having our parent function like we had, we're going to have it plus 3. It's going to shift it up 3 units. So this time we actually picked up the entire graph and we actually moved it all up. So that's actually going to change your asymptote, your y-intercept, and your range. Domain gets to stay the same. Like I said, he doesn't change at all. So our y-intercept is 0, 4. Because 2 to the first is 1. 1 plus 3 is 4. The asymptote, what line am I getting close to and never stopping? Well, I went up 3 units. And so it was originally, our asymptotes have been at 0. If I go up 3 units from 0, that means 3. Our range is going to take this 3, and I'm going to go up from it, so it's our starting number, comma, infinity. So on this case, we have minus 4 that's happening to this equation. Which of these do you think is going to change? You're right, y-intercept, asymptote, and range, all 3 change. And so our y-intercept has moved. We're now at 0, negative 3, because I went from 1 minus 4 is 3, because our original one's at 1. And so 0, negative 3. The asymptote is this line it doesn't cross. And that line was at 0. I moved it down 4, so y equals negative 4. Our domain gets to stay the same. No changes. Our range, we're still going up, so the negative 4 is our starting point. And we're going to end at positive infinity. Let you graph y equals 2 to the x minus 5 and find out what pieces this has. So our y-intercept is y equals, was 0. And we went down 5, so that meant negative 4. Our asymptote is y equals negative 5. And our domain, negative infinity to positive infinity. And range, negative 5 to positive infinity. So when you have a D at the end, it's either going to move your graph up or down. It's going to change your asymptote. It's going to change your range. And of course, it changes your y-intercept. So what if it was in the exponent that it changed? So the inside of it. So if I had x minus 4 as the exponent as opposed to just an x, what things do you think are going to change? Well, you said the y-intercept is going to change. And so the blue is a new one. And it's like we took our graph and we moved it to the right. But that means we took what was 4 units to the right and moved it over. If you click on it, and I thought I gave you all the picture with it clicked on, it gives you a decimal. The decimal is going to be hard to work with. The computers are going to want you to tell it exact. So go ahead and do 0 minus 4. And so y equals 2 to the negative fourth power, which is 1 over 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 1/16. So my y-intercept is 0, 1/16. Did our asymptote change? Did this line that we're not crossing change? No. So y equals 0. Does the domain change? No. On none of these, the domain will change. The domain will be negative infinity to positive infinity. We are going to cover every x. There's no x that we won't cover. And then our range. So our lowest down is going to be where the asymptote is, and it's going to go up to positive infinity. So when it was minus 4 in the minus in the exponent, we went right 4. What do you think is going to happen when we have a plus 2 in the exponent? If you answered go left 2, so that spot is going to become over 2 units to the left. So my new y-intercept is 0, 4. Our asymptote has not changed on this one. So y equals 0. Our asymptote is only going to change if we change the horizontal position. Our domain will not change through any of these exponentials. And our range, we are going up, so we start at 0 and go up to positive infinity. I want y'all to do this one on your own. You should have found out the y-intercept was 0, 8. The asymptote was y equals 0. Domain is negative infinity to positive infinity. And range starts at the 0 and goes to positive infinity. So when you're changing in the exponent, it's going to be no change to the domain or range and no change to the asymptote. The shift, remember, is going to behave opposite. And so if it's a minus, it's going to become plus. And so we'll go right 3 if it was subtracted.